Hello, I'm Aiden Gallagher and I'm a solution architect in Technology Expert Labs, and I'm a product specialist in various integration tools, including API Connect, but not as much as you two are. Chris, do you want to introduce yourself?
Cheers, thanks, Aiden. So I'm Chris Phillips. I'm a worldwide Tiger Team lead or Tiger Team chief architect now for IBM Integration. My specialist topic here today is API Connect. I've been using API Connect since about 10 years, partially in Expert Labs, then in the SWAT team, which we've now recently rebranded as the Tiger Team. I'm the author of the deployment white paper guide for version 2018 onwards, and I've been probably 20 odd countries around the world working directly with customers using API Connect, as well as the engineering teams. Now, but Simon here, do you want to introduce yourself as well?
Sure. My name's Simon Kapadia. I'm the security architect for the API Connect product, and I've been in development for, crikey, it's been 10 years now. Before that, I spent about 15 years working in consulting, so software services, WebSphere, the same kind of thing as Aiden does nowadays, and Chris has been through that as well. So, yeah, I'm just think of me as the security guy. That's been my role for decades now. I've got the grey beard to show that I can get away with saying decades nowadays.
What are the main concerns with API development, just generally, in the industry? When I think of API development, one of the main concerns I think of is probably around making sure that developers are sticking to a framework, trying to make sure that you're introducing specific security standards, whether that's, I don't know, we talk about OAuth or JOT tokens or whatever it is. It's trying to make sure that developers are being secure. What are your thoughts on how does API Connect do that? How does it enable that?
So this is a great point, and I just want to go back to the problem statement first a little bit more. Is developers can develop whatever they want, but we've got to make sure what they're developing is also what the platform owners and the company needs as well. Security is an area that often gets overlooked, like all non-functionals. Let's be clear, this is not just an issue with security, but non-functionals often get overlooked because they're not as interesting as the functional work. I mean, now Simon might challenge me on that one.
Not in the slightest.
So the best way to always look at this is let's start from a platform side and then delve into individual sort of API patterns. Is what does the platform require? I mean, it's quite frequent that things like API keys or client ID, client secrets are sufficient. Not always. But it's quite often they are seen to be sufficient. Also, we can see things like OAuth put in place as well, OIDC, and then we can get more and more advanced or more custom bespoke solutions depending on the individual requirements. But just having those requirements is not always enough in the development process. And I'm going to talk about the API Connect has recently added some governance capabilities here that you can run a set of rules over APIs to ensure that certain settings are set. One of these, in my opinion, probably the most important, is the one to validate the security settings are correctly configured. So we can actually capture some of these now prior to deployment. What's your view on this, Simon?
No, I absolutely agree. I think it'd be interesting to go through the governance story. I know that you know that quite well because you've demonstrated it a bit. So maybe you can sort of expand on that a bit. That's something that I think we should be promoting to people a lot more than we do.
So the governance is a topic I've been talking about 15 years of my 17-year career in technology because of my background on governance platforms for SOA as well. And governance is a challenging thing to get right first time. The key thing is to understanding, and one of the many pillars of governance is consistency and ensuring that we're catching things as early as possible around that. So API Connect allows you to use things like spectral rules to run these rules over the APIs, and we can capture things. Now, these can be used to check, do we set examples? Do we set security standards? As I said before, I've written some custom rules that will interrogate some of the gateway script code in API Connect to look for bad coding patterns. And so we can use these rules to help capture this. And if we can get these implemented as early and as shifted as far left as possible, we can catch these mistakes before they go through QA, never mind going to prod. And also, by enforcing these rules, we can ensure consistency between the APIs. One of the things that when you have a large organization who have many different teams building APIs, is the challenge of consistency between each of these teams. How do we ensure that the team A and team B, they work in the same company on this and similar things? They may have their own paradigms or their own technologies or their own wording for how they do stuff. And we need to unify that, because the consumer doesn't want to have to learn how to do this twice. They want to do it just once. And so using the governance facility in API Connect, we can start to try and capture this and ensure that we're using the right sort of language to ensure that consumer only has to learn everything once, not multiple times for each different API. That's kind of my view on governance in a couple of seconds. I mean, Aiden, I want to throw this over to you. What's your view? How does this match what you've seen recently in the field?
So I am gonna start with a question, which is: would you see the API governance as similar to static code analysis rules that previously customers would have put in things like Jenkins or their pipelines?
Absolutely. It is an aspect of that, is that you are doing analysis of the specification. The key thing, though, is you're not just analyzing the specification, you're also ensuring this is part of your process for publishing APIs, whether part of your CI/CD. And so you're actually not just detecting it, you're enforcing it, because any rule that's not enforced doesn't need to exist. And
this is what I'm thinking. So customers typically today, well, if they want to do that, have to do it in static code analysis in their pipelines, and that really pushes the policy enforcement sometimes to automation SMEs, not the managers of the API platform. It can mean things that get missed because everything's manually constructed within the static code analysis. Really, it's a way for us to do static code analysis out of the box within API Connect, and I think that's probably where developers will be more familiar with what API governance does and why it's there, if it's compared to the static code analysis side of things on the DevOps side.
There is one additional thing that adds though as well, is you can if you are changing your rules, there is an inbuilt facility to run it over your published APIs. So let's say you're thinking, I think maybe we should modify this rule so that we must also include examples in our descriptions. This may not be in the principle day one, but it's added in year 2 because you think this will help. You could create that rule, running it over your currently deployed APIs, and pull it out. Now, yes, this is still just static code analysis, but we provide the capability of doing that against what's currently running as well. So we're not just having to wait for the next deployment and catch on the next deployment. And therefore, we can then understand the scope of the changes that will be needed.
Absolutely, Chris. I mean, I was jumping up to turn my mic on to say exactly the same thing. It's about doing this at runtime on existing configuration which is out there. People put a lot of emphasis on DevOps pipelines and on doing this as you're deploying, and then they forget that once they've deployed, that code is still there and it's running and it's doing things. And if you make changes in your pipeline, unless you actually redeploy things, then it's not going to change what's currently running there. One other point I'd make is that this is an area you need to invest some time in. There's no magic here that, we're not generating these rules automatically for you without any kind of thought. I mean, maybe that's a future kind of direction, but right now you have to invest some time in writing these spectral rules and making them useful, making them do what you want them to do. There's, I've spoken to customers who have said, oh yeah, we're using the API governance, and I say, what rules are you? Oh, we're just doing the stuff that's out of the box. That's
step one.
A challenging question, a challenging statement, shall we say?
I mean, I'm going to be a little bit controversial here and do something that I don't like to do and disagree with Simon. I would rather a customer is using out of the box rules than not doing anything at all. But your point, which I think you're making, is that may not be sufficient, and we need to look beyond that, because we don't know how businesses, their specific business is going to be run. We have an idea how the industry works, we have an idea of the principles, but we can't build rules tailored for a particular customer. And that's where Simon's point here is spot on, is they need to look beyond just the basics and actually tailor this. But I would also say doing just the basics is better than doing nothing at all.
No, absolutely agreed. We've been through multiple iterations of this when we used to work with, raw data power policies, and we'd write SQL injection protections style sheets. And when we wrote those style sheets, we'd have to look at the customer's database, look at the data itself, see what calls they're making, and tailor those style sheets to their database. But we had customers who said, just give me the default and run it, and that will be protection. And they tick the SQL injection protection box. And then they'd come back later and say, but this allowed SQL injection protection into this use case. And it's, it's a piece of use case that we never envisaged because it's very specific to their thing. And I fear exactly the same kind of thing for customers that don't consider the rules. But I absolutely agree. Doing the out of the box stuff is much better than not doing anything at all. It's the first step. And that's the point that I'm kind of trying to make.
Yep. If I ask a broader question, then who is responsible for security at the API Connect level? Is it developers? Is it enterprise teams making the governance rules? Who's making these security rules, and what's the right point in the sort of API development journey?
Everyone is responsible for security, Aiden. Sorry, we'll leave the religious topics behind.
I was going to say the same thing, Simon, but I was going to say everyone is responsible for security. But security is not a simple, single-faceted thing either. So everyone is responsible for all of the facets, but some people are more responsible than others for different parts of it.
So okay, if I tailor my question, because I was very broad, who do you see creating the API governance? Is it individual provider org, so the provider of the APIs, or is it enterprise governance, or is it a mix of both, depending on, like, say, the use cases, Simon?
No, I need to think about that, because it seems to be different for each customer. What we need is ownership. That's the fundamental key. Where that ownership lies can be different with each customer, and I don't really mind. In my experience working with customers, there's always somewhere that actually cares about security. And those are the people that I like to try and find and work with. And sometimes that means we're working with a network team and they're enforcing requirements, and they go up to the API folks and say, you have to do X, Y, and Z. And they're actually stating things that are way beyond their typical remit, but they're the ones that care about the security, and therefore they're pushing it up. Sometimes you have, some of the more mature customers that we have, they put formal processes around this, and they create security architecture centers of excellence and push things down. I've also seen some bad examples of that. They have a center of excellence which says lots of great things, and it seems like everything's going really well, and they report up to their management that everything's going well, but they don't have any enforcement power, so everyone just ignores what they say and doesn't actually do it. So it's really about ownership, and wherever the ownership of that in the organization is, if that doesn't exist, then things will not go well. I know that's a wishy-washy answer. Chris, any thoughts?
I'm going to take your answer and extend on it a bit. Ownership obviously is key here. For me, it depends on how they are exposing their APIs. If they're exposing all their APIs as a single catalog, as a single channel, then yes, I would then say that the centralized team. Now this is expose them, not producing them. So if you could have multiple teams building APIs, but running on a single platform that is contained by its own team, so the decentralized governance approach. In my opinion, then the platform owners would have the skin in the game to own that responsibility, working with the security owners as well. And the platform owners are the ones who will be implementing the rules that they've come up with the security owners. If we are saying each team has its own sort of mechanism for exposing APIs that are independent, so a different catalog per team, then I'd probably look at it on the way as the team is then responsible for doing that themselves, because they are not trying to play in a common environment, they're trying to play in their own environment, and therefore they have more control over their own rules because it's not a shared space. That's my view here, but I'm sure we could come across many customers who would have a different view. So a lot of this is very subjective.
I'm going to pull you back on the Center of Excellence piece you said, Simon. So what I have seen a lot more in customer engagements is actually that there is, my view, an over prescription of OAuth. Possibly it's a new paradigm. We like new things. Therefore will go in and a bit like I was saying about standards being placed there. I feel like some security teams have said OAuth is a stronger authentication method than what they see in things like client ID, client secret. Therefore, OAuth will be everywhere, and that's somehow become mandatory sometimes without thinking about the use case. So I wondered if either of you had thoughts on the topic of OAuth usage.
Oh,
would it be convenient for Simon to do a one-sentence explanation of OAuth, just for those viewers who aren't aware of the details?
Right, yeah, just put me on the spot, why don't we?
That's my job.
I can't do this in one sentence, though. That's the trouble. I mean, OAuth is interesting. OAuth is historically was created not for the kind of use cases that we use today. You know, OAuth's use case was when I have some resources on one system that I am the resource owner of, and I want to grant someone else access to those resources while I'm not there. So it's a three-party system, and we have different concepts of the resource server, of the authorization server, of the OAuth client, of the end user. It's a very complex topic. It's not something you can knock down into one single sentence. The problem is, for its use case, for what it was designed to do, it was very, very good. But people picked it up because technology works in a kind of circle. You know, we've gone through phases where you have you start off with something where you've got this is a new technology we're playing with, let's do it. Let's add some security, and we put some very simple noddy security. Then it grows and we have more requirements turn up, and therefore we have to complicate the security and make it able to do more things, which makes it harder to use, which makes it more complex, and it sort of grows in and of itself. And we've gone through that with look, if you look back at SAML and IDPs and SOAP and so on, it's the same thing. I mean, we're just in IT, we're re-implementing the same thing over and over again. If you go back to DCERPCs that I was working with 30 years ago, that's exactly the same as a web service, which is exactly the same as a JSON service. With all of this is fundamentally remote procedure calls. That's what an API is. It's the same as you used to call to a mainframe when we were trunking LU 6.2 transactions over to via two-phase commit to a kick system running on a we call them Z series nowadays, on a mainframe. So it's the same thing over and over. At the time that OAuth started becoming popular, people said, here's something we could relatively easily start to use to authenticate these APIs. And we're using it here for this use case anyway. Why don't we use it here? And people then started implementing OAuth services, and they started adding bits and saying, okay, well, we're using this for authorization. Let's add identity concepts to it as well. And they started putting things in, and it started to grow, and it got a critical mass, and then everyone wanted to use it. And then you have schemes that are built on top of it. So OIDC is actually a scheme that sits on top of OAuth. It's like an extension of it, and it requires OAuth under the covers. And it's about identity as opposed to just authorization and tokens, because that's an extra requirement that came into the mix, and it sort of grows and goes on. Was it originally designed to do what we wanted to do right now? No. Does everybody use it nowadays because everyone and their dog speaks OAuth? Yes. I mean, right now people are mandating OAuth is the way you should do this. The use cases aren't always exactly, what they probably should be, but it now is something that you can use, and it's like sticky glue. You can use OAuth to talk to everything, and therefore it becomes popular and it's easy to use, and people therefore mandate it, and therefore it becomes easier to use and more popular. And it's going to keep growing until we get to the next stage in the cycle, and we'll see what happens then. I'm sorry if I've jumped into a bit of a spiel, but that's
what
you wanted a one sentence explanation. There's my history. Go for it.
So that should answer all our questions on OAuth, I believe now.
Yeah, definitely. Is it that OAuth then? So OAuth is good at authorizing users to specific resources, and they can be and I've seen it used in like scopes used to give access to pretty much everything. It's like, okay, so you've missed the point slightly. And obviously partially that's education. Is OAuth innately more expensive than doing like API keys, client ID, client secret, username, password? Is the expense worth the sort of security it could give if used correctly?
There are pros and cons to every approach. So OAuth has a lot of power. If you model things like scopes sensibly, and you define authorization constraints and use OAuth scopes as a relatively coarse-grained authorization mechanism, for example, and then you have applications which then require more fine-grained authorization mechanisms, and they can base that on something else which is relevant to that specific application. You can design these things quite well and get a system that works very well. We have in the product, in API Connect, we have what we call a native OAuth provider, which we provide to our customers. And we say, here's the native OAuth provider. If you don't have an existing OAuth provider implementation, and you want to test things out with OAuth and use it, go ahead and use this. And we have customers who come to us and say, okay, well, we're using your native OAuth provider implementation, and it doesn't do X, Y, and Z, which a commercial OAuth provider would do. So, for example, if they went to IBM Security Verify, which is the IBM commercial OAuth provider, it has a lot more function and features and capabilities. And they say, OAuth is OAuth is OAuth. And I say, no, that's not what the native provider that we give you is designed for. The native provider that we give you is designed for you to take and use OAuth for your test usage and for your, for getting used to OAuth and for use cases where you don't have, complex and advanced requirements. It should be used for small, dedicated, focused tasks and not for. So, for example, DataPower doesn't have native capabilities to provide you with, user management and all of these things around. It's basically designed as a small scale thing for protecting APIs.
So API Connect has its native OAuth provider in DataPower, as Simon said. It can do OIDC as well, and this does meet the majority of use cases where the having standard implementations are being used. And also we can use third-party OAuth providers, such as IBM Verify, as Simon said as well. And it's all about understanding what is the requirements and what is the needs. And I'm confusing my camera focus. It's all about understanding the requirements and the need. But so in terms of using OAuth to expose APIs, great, awesome. But one of the areas that I wanted to bring to this conversation, Aiden, is using how do we do security between the different layers? At the end of the day, API Connect is a way of exposing your systems to make them more consumable and have a standardized approach for things like security, which is why we're here, and many other things. But when we make downstream calls, yes, some clients use OIDC and OAuth for those, but I'm always more keen to use things like MTLS or to use just API keys to secure the downstream levels, because in my mind, there's slightly less moving parts. Now, certificates is sometimes not everyone's favorite or sexy topics because they in themselves are complex. But I'm going to put you on the spot here, Aiden. So what is your thoughts on how we do downstream calls from API Connect to where the downstream is? What about MTLS? What about API keys? What about no security at all? I think we'd all agree that was bad. Let's leave that one out. But what's your view and what have you seen?
Well, I'm not going to contradict you, but I will give a full answer, which is my personal view is that I'd always secure everything across everywhere, and that's because you don't know where the backends might move to in the future. Some things might move without you knowing. So if you're calling, say for example, you're calling a backend microservice, you don't know if that's going to be on premise or if it's going to be on cloud the next day. So you do want a level of security between those. The conversation I have with customers a lot is they say, well, everything's in my network, and previously in my own network I wouldn't have secured between my systems. They might have said that. You might have disagreed with them, Chris, but they would have said
yes,
that.
I hear that weekly. We have
a flat network, so it's fine. I get I do get the point, because obviously MTLS does add historically added more, but it does add a bit of core compute. But I don't really see that being a problem anymore. That I've never seen humongous performance impacts by securing channel connections between pods on APIC, for example, with MTLS. It's not even don't shoot me, but it's not even that difficult to set up. If you're getting signed certificates from your CA. So I'd always use MTLS, and I would separate out channel level security to application level. So API keys, in my view, are application based authorization, whereas the MTLS is more, this pod is talking to this pod, these are the correct pods talking to each other. The API key is, this API is permitted to call this API. So there's different levels on there, and I always start conversations with customers about the fact that channel and application security are two separate things, and you need to sort of treat them as such.
Yeah. Can I jump in on this one?
Of course.
So this is an area that really needs to look at what the actual requirements are for the backend systems, because we're an API service. That means that we're fronting APIs, but those APIs can be all sorts of different things. I've seen customers use API Connect to integrate directly to a legacy system on the back end, which has very little capabilities of security. So what you do is you chunk back and you look at the requirements. So for example, let's say the backend is it's a system which needs to know the identity of the user that came at the front end, but it doesn't support any modern mechanisms, because the only way that you that it understands identity is with when a user logs in directly to it with its local username and password. And I've had a customer who came up with a mechanism for asserting identity to that. What they did is they had a single username at the configured on the backend system, and when this username came in, it was basically a special user, a super user, and it would then provide, when authenticated with that username and a secret password, it would provide the ability to state in a header, here is the user in the front end that should be authenticated. Now, what have we done? So you've got the concept of a super user, and some people might say, oh, that's terrible. You're giving all of this privilege to a backend system, and it shouldn't be doing it. But take a look at what you're actually doing there. You're passing over a secret, which is the password for that super user, which is a long randomly generated string, maybe some base 64 characters or something. And in that long randomly generated string, that's a token. I mean, it's something that you could take, you could put governance around it and say, it has to be X long, it has to be changed every so often. So you're passing a token. Encrypt the connection. Okay, most systems at the back end can use a transport level encryption, and you have a TLS encrypted connection with a token, which then allows for identity propagation, and the back end system trusts the front end system to send that information across. Identity propagation is a requirement, and it's met. It's all about finding the specific requirements that these back end systems need and using what's appropriate. Now, if a back end system uses something that we easily support out of the box and everything's good, that's fine, but that doesn't seem to me to be the norm. I mean, maybe I'm a little bit skewed, because usually it's the customers with problems that end up having to talk to me. How do we fix this? How do we fix that? How do we integrate with this? But realistically, our customers aren't in this business to try and support the latest standards and do the latest things. Our customers are in this business to provide a business service securely to their customers. So we need to think about the appropriate security to enable them to support and their function in business.
So if we take this conversation and so take it to the next step, we've covered the governance, we've covered securing your APIs and securing the communication downstream. Security is a very wide topic, and we're not going to cover all of this on this one session here today. But an area that I've been looking at more and more in the last few years is things around validating payloads. So we're not just talking about ensuring the connection is secure. We're ensuring that the connection is high quality and the requests are of high quality. And also just limiting connectivity to ensure that people aren't exploiting or putting the system under too much pressure to protect each area. So I'm going to do talking a little bit about payload validation. And then I want to talk a little bit about rate limiting and concurrency limiting. And then maybe we can talk about IP blocking if there's time at the end. So API Connect has the facility to validate payloads. And I'm not going to sit here and say everyone should validate every single request and response. I mean, I think they should, but I also live in the real world as that is computationally expensive. When you have low latency requirements, validating every payload on a high throughput system may not be the right decision. But it's one of those things where the default answer should always be, yes, we should validate it unless we have good reason not to. We have the facility to validate different schemas, and I would always validate the request and the response. The worst thing for the downstream application is to get a request that's identified but is not actually useful because you're just wasting compute time. And one of the many worst things for the consumer is to get a response that's not at all what they're expecting in the format that they can handle. So having this validation on your assembly flow is critical. And if compute cost was never a concern, I would make sure that we are validating the request and response at every layer going through this, not just the API layer. I would do it at the business layer as well, so we can capture this as soon as possible and propagate the correct responses back through. Now, what is your view here, Simon?
Absolutely, yes. Schema validation has been a vital function of a front-end API gateway for a long time. I mean, thinking back to the whole sales pitch for Data Power at the very beginning was wire speed XML processing. Why did you want to do that wire speed XML processing? It was because we needed to do well-formedness checking and schema validation.
Yes.
Now, the dangerous part of this is where people, again, take out of the box and click the button and say validate schema, and then you look at their schema and their schema says blob of XML or blob of JSON or blob of data, and that's it. Schemas need to be useful. They need to actually define what the message should look like and be specific. If you just have something that says here's a username, here's a password, and they can be anything, then in that username you could have a base64 encoded piece of malicious data, and it's just there, and your schema isn't going to pick that up. You have to be specific when you're creating these schemas for the validation to be as useful as it can be. What we do get automatically by doing basic validation is we're actually passing the payload itself and making sure that it is well formed. So at least when we pass it to a backend system, it's not going to turn around and say, oh, I can't pass that. I've spent a whole bunch of compute time. I prefer to do that out at the front as soon as possible, so we don't pass anything back that's not well formed and correct, and at least meets the basic requirements. But if we're talking from a security point of view, from a payload validation point of view, make your schemas specific and make them meaningful
and useful. Meaningful and useful.
And how hard is that to add after? So I'm thinking we are obviously of the opinion we are security first, most security is the best, and what we'll do, or at least I do, we start at the top, we say the most secure, and then we sort of pull apart little bits until we get to a bit with something that people are happy with at the business level. So you sort of pull apart until you've got the most security that is acceptable. Now, a lot of development practices is all about getting out fast, getting things into production fast, and proving out concepts as quickly as possible. How hard is it to add sort of schema validation after the fact? So get something working and then secure it afterwards, or does it all have to be upfront?
If I may, because this is a particular passion of mine, we're entering a phase now where doing the stuff that's boring and that we don't want to do is becoming easier because we have large language models and AI to help us, and getting something like, I don't know, what do we call it nowadays, Watson Code Assist or whatever the AI and large language model of the day is, to take a look and analyze existing data and generate a schema based on that data, which of course you have to validate because these things do make mistakes, but it makes it so much easier to do. It makes it so plausible and possible to actually do this and get the benefit with relatively little cost. Like I say, it's become a bit of a passion of mine nowadays, and I'm trying to push that through the API Connect development organization now. I'm saying there are so many things that people are saying, oh no, we can't do that. That will take forever. Last night I sat down, I spent a couple of hours with our internal AI system and generated a bunch of code that did something that someone told me would take a week to do, and it took me an hour and a half. Okay, is that production ready code and perfect? No, it's not, but this is the world that we're living in now, and using that for use cases like generating a good, strong schema whose intention is to protect the data that comes in and define exactly what it should look like, that's exactly what the world we're living in should provides.
And from my view, and I agree completely with everything Simon just said, but from my perspective, an API specification should already have the schema in it. So if the schema is already in the specification, how hard is this to build? 10 clicks, maybe less. So Simon's right completely. There's no excuse not to have the schema in this day and age, not just from a security perspective, but from a good schema perspective as well. How can we tell people how to use our APIs without a high quality schema? If we don't include in there the understanding of what the payload should look like, that's a lot more effort for them to learn. And so schemas and examples, I think, are key for all APIs. Not that I do that on all of my personal ones, but I should, and I should be beaten up for not doing them.
So what we've said what we've got to in this podcast, what the outcomes that we're really talking about, is that we think that strong ownership within the API Connect spectrum is important, especially around security. So somebody who understands or will take ownership of security aspects, that allows us to make correct decisions based on requirements, and it means that we're honing solutions to actual use cases. We're not arbitrarily saying we're going to do X, Y, or Z to this API because that's what everybody else does. So looking at everything slightly fresh, reuse patterns by all means, but looking at everything and saying, does this make sense for this use case? That's the two main threads that I've got from here. And start from the most secure, and then slowly pick a way to get to what everybody's sort of happy with. But start from the most secure and pick your way down. Don't start unsecure and trying to build security up, because often what we see is that actually that security never gets in. Chris and Simon?
I would like to just go on your last point, and the way I phrase exactly the same thing is you start with the most secure, and then you decide what to cut out, because then you understand the consequences of that decision. If you start with the least secure, you just look at the consequences of making it more secure, which could be the costs, and you may miss the overriding point. But Aiden, that's something I've been preaching for as long as you've been knowing me. So, and Simon, over to you.
Yeah, I've nothing to add. That's absolutely spot on. So, focus on your security. That's all I can say.
Well, thank you very much for listening, and we hope to see you again soon.
Thank you.
Thank you. Bye.